While earthquakes can easily cause massive loss of life and property within a very short time, even today there is no entirely accurate way of forecasting when and where earthquakes will strike. Because of this, earthquakes can be considered random killers. Although we cannot stop earthquakes from happening, scientists and researchers are still working tirelessly in hope of making breakthroughs in forecasting earthquakes and mitigating their damage, and together help build an earthquake-proof, sustainable homeland. Located at the junction of the Eurasian and Philippine sea plates, Taiwan is the site of intense earthquake activity. As a result, the government of Taiwan has been paying close attention to ways of alleviating loss of lives and property by preventing the destruction of buildings in earthquakes. In order to overcome bottlenecks in earthquake engineering research and take the domestic earthquake engineering research to the next level, the National Science Council of the Executive Yuan established the National Center for Research on Earthquake Engineering, NCREE, in 1990. Researchers at NCREE employ the results of large-scale, quasi-static and dynamic experiments to verify theory and effectively reduce the damage caused by earthquakes, safeguarding the nation's economic achievements. The National Science Council established the National Applied Research Laboratories, NAR Labs, in June 2003 for the purpose of strengthening the operational flexibility and efficiency of the nation's research units. NAR Labs assumes control of all national laboratories, including NCREE, which has continued to carry out its crucial mission of earthquake disaster prevention in Taiwan. NCREE's main missions currently include establishing and providing experimental facilities and earthquake engineering databases, leading the development of seismic design codes, bridging between academic and industrial sectors, playing the role of coordination and integration, leading the way for the innovation of seismic technology, and spreading and popularizing seismic knowledge. In order to accomplish its missions under the leadership of the Director General and 2 Deputy Directors General, NCREE has established separate administrative support and specialized technology divisions, while also making flexible adjustments in accordance with emerging research needs so as to achieve the best effectiveness. NCREE's Earthquake Simulation Laboratory possesses experimental facilities meeting the highest international standards, including a seismic simulation shake table, reaction wall and strong floor, and multi-axial testing system. Seismic Simulation Shake Table. The Seismic Simulation Shake Table has 6 degrees of freedom and can simulate major natural earthquakes as well as artificial earthquakes. With dimensions of 5 meters by 5 meters, the shake table is capable of carrying a maximum payload of 50 tons and is driven by 12 actuators along 3 axes. The shake table is secured on a reaction mass block weighing 4,000 tons. 96 air springs and 80 viscous dampers make up the isolation system to separate the table from the laboratory foundation and keep the laboratory structure free from the shake table vibrations. Reaction wall and strong floor. The reaction wall and strong floor experimental system can perform quasi-static monotonic or cyclic loading and pseudodynamic testing of large or full-size structures. The reaction wall is used to secure the hydraulic actuators and provides the reaction needed on structural tests. L-shaped in plan view, the reaction wall system has a cell-type construction and features a unique artistic design with wall heights varying from 15 meters, 12 meters, 9 meters to 6 meters. The strong floor is mainly used to mount the structure specimens, It has a reinforced concrete construction and dimensions of 60 meters length, 29 meters width, and 1.2 meters thickness. In addition, a testing system for energy dissipating elements is provided to perform dynamic cyclic loading tests on energy dissipating element. The facility is fully able to support seismic performance verification, code development, R&D of new generation technologies, and construction methods in industrial, governmental, and academic sectors. Multi-axial testing system, MATS. MATS is a structural testing system with 6 degrees of freedom, capable of applying vertical loads, lateral loads, transverse loads, as well as bending moments in all 3 directions. The maximum vertical force capacity is 6,000 tons. The maximum horizontal displacement is plus or minus 1.2 meters. And the maximum horizontal tension compression force capacity is 700 tons. In comparison with equipment used in the past, this system can simulate an even wider range of structures subject to actual forces or deformations. The system can be used to test many different types of structural elements and subassemblages. NCREE's Earthquake Simulation Laboratory and Calibration Laboratory have both passed ISO 17025 certification, and its Earthquake Simulation Laboratory has also passed ISO 9001 certification, assuring the quality of earthquake engineering experiments. After being in operation for more than 20 years, thanks to the teamwork and dedicated efforts of all employees and other earthquake engineering partners, NCREE has achieved many impressive R&D results in the following areas. In the area of seismic assessment and retrofit of existing structures, NCREE has been continuing to take the lead to perform seismic assessment of a large number of buildings and bridges in recent years, and provides a feasible portfolio of seismic retrofit recommendations. NCREE has been steadily improving the domestic structural seismic assessment and retrofit technologies through conducting a variety of advanced structural experiments, particularly in situ full-scale tests of elementary and middle school buildings and bridges. The School Building Seismic Design and Retrofit Project, spearheaded by NCREE's Building Division, has brought about a major improvement in Taiwan's school building seismic resistance capabilities and holds educational training classes and workshops in order to enhance the professional skills of relevant personnel. The outstanding performance of this project was recognized by the Executive Yuan with the 2011 Award for Outstanding Contributions in Science and Technologies. In the area of seismic design codes, NCREE helps government agencies such as the Ministry of Transportation and Communications and the Ministry of the Interior to draft various types of seismic design codes in line with the principles of feasibility, efficiency, and safety. NCREE also regularly convenes its Codes and Standards Committee to review relevant issues and submit recommended revisions, while also performing research on the next generation of performance-based seismic design codes. In the area of earthquake risk assessment, in addition to compilation of a comprehensive earthquake engineering database, NCREE has also integrated various earthquake damage loss assessment models and parameters to develop the Taiwan Earthquake Loss Estimation System, TELUS, which can estimate probable earthquake damage to various civil structures and industrial facilities. The system's early seismic loss estimation module can use cell phone text messages, email, or website query information to notify relevant personnel of the scale and distribution of possible earthquake damage within 1 to 5 minutes after an earthquake occurs, providing critical information needed to guide preliminary earthquake emergency response actions. In the area of new technologies and construction methods, experiment results and system development. N-slot buckling restrained brace, BRB. Buckling restrained braces are highly economical, high-performance damping devices that can dramatically reduce the swaying of buildings via the dissipation of seismic energy. The welded N-slot buckling restrained brace, developed at NCREE, is easy to manufacture and install. It is already in widespread use in buildings throughout Taiwan. In addition, engineers can use the Brace on Demand (BOD) software developed at NCREE to perform automated design and inspection work via cloud computing and dynamically produce structural calculation documents and statements, enhancing the quality and quantity of design works. On-Site Earthquake Early Warning System (EEWS). This system can provide early warning of earthquakes before they can be felt. The system can be combined with an intelligent control system to automatically shut off gas lines, stop elevators, open up emergency exit doors, and turn on LED escape guidance lights while issuing the warning. Multi-roller bearing seismic isolator. This device can effectively reduce the transmission of seismic forces to equipment or facilities sitting on top of it while maintaining a stable response through the use of an excellent seismic isolation mechanism and self-centering capability. Innovative construction methods and applications. Precast segmental post-tensioned concrete bridge columns. This working method involves the use of precast concrete segments, which can be stacked to form bridge piers. This method can dramatically reduce the impact of construction work on the environment and traffic, and has been widely deployed in the construction of elevated highway along Line 4 in the Taichung metropolitan area. Bridge monitoring. Fiber optic entire bridge monitoring system. This technology employs fiber optic cables and sensors to simultaneously monitor river water level, bridge deck condition, bridge pier elevations, and bridge cable tensions. The technology is already in use at many bridges in Taiwan. As soon as any unusual problem happens to the bridge, its monitoring system will promptly notify managers, allowing damage to be contained. Bridge scouring warning system. This system can monitor bridge scouring in real time, provide automatic early warnings, and report accurate bridge condition to decision makers while typhoons or floods are occurring. The system has passed hydraulic simulation tests in the laboratory and is undergoing on-site reliability testing on the Highway Number 1 and Number 3 bridges over the Dajia River, the Shuangyuan Bridge, and the Zhongsha Bridge. Analysis software development. PISA 3D. The new generation PISA 3D structural analysis software can accurately predict building responses under earthquake excitation. Compared with other software in the same class, the PISA 3D software can save up to 90% of the computational time needed for numerical analysis, and its 3D graphical visualization interface provides its users a convenient and faster operation platform. In the area of geotechnical engineering and seismic potentials, since soil liquefaction induced by earthquakes can cause tremendous damage to civil structures, NCREE has performed shaking table experiments involving a bidirectional soil shear box to gain a better understanding of the interaction between structure and its surrounding soil. The results of this work can be helpful for disaster mitigation in the event of an earthquake. Furthermore, NCREE is collaborating with the Central Weather Bureau in taking geological core samples from the locations of monitoring stations in Taiwan's strong motion network and establishing an engineering geology database. NCREE has further performed seismic and geochemical monitoring on selected major faults in an effort to assess possible earthquake potentials and obtain supporting information to guide seismic design and deployment of regional earthquake early warning systems. Promotion, education and extension activities. NCREE is a member of the Asian Pacific Network of Centers for Earthquake Engineering Research, ANSER, and has cooperation or research agreements with seismic research institutes in the European Union, Canada, the United States, Japan, and Britain. To date, NCREE has held many sessions of the International Training Program for Seismic Design of Structures, which is geared to help developing countries to upgrade their structural seismic design technology. NCREE also relies on international conferences, domestic symposia, and the publication of research papers to help increase Taiwan's contributions to the international earthquake engineering community. Furthermore, NCREE has conducted numerous educational extension activities, including Earthquake Week and introducing and demonstrating earthquake engineering research in schools, ideas, seismic design contests. These fun and educational activities have increased public awareness of earthquake resistance and damage prevention concepts.
国家地震工程研究中心已经成立了20多年了，在中心全体同仁的努力之下，我们已经有许多重要的研究成果，并且落实在国内的产业应用上。在未来，我们将秉持着国研院承诺、热情与创新的理念，并配合我们政前准备、政时应变以及政后复健的任务要求，来培训我们国内相关的研究以及工程人员，让地震工程减灾的工作能够有效地进行。我们期望国家地震工程研究中心能够变成一个研究卓越而且有具体贡献的国际级地震工程研究重镇。
In recent years, the focus of earthquake engineering research at NCREE has evolved from the basic requirement of structural integrity in major earthquakes, no damage in minor earthquakes, to strengthening the nation's ability to fast recover from earthquakes. In line with contemporary trends, NCREE is pursuing 3 major R&D directions and training domestic research manpower as it strives to build an earthquake-proof, sustainable homeland.